Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over problems 35 through 39 of the Algebra 2 Trigonometry Regents exam for the year 2015, and this is January 2015. All right, let's take a look at problem 35. It reads, the area of a parallelogram is 594, and the lengths of its sides are 32 and 46. Determine to the nearest tenth of a degree the measure of the acute angle of the parallelogram. Now, one thing you want to note about parallelograms and triangles is that the area of a parallelogram and that of a triangle can easily be found when given the measure of two adjacent sides and the included angle. Okay, so every parallelogram is basically a combination of two triangles, right? So the formula that we are applying to a parallelogram, if you split that in half, is applicable to triangles also. In this problem, these are the steps we're going to execute. First of all, we're going to write down the formula for finding the area of a parallelogram given two sides and an included angle. And then after doing that, we're going to find the value of the variables we know. We'll identify our unknown, substitute them into the formula, and then we'll solve for the unknown variable. Okay? All right, so let's get started by giving ourselves a visual for this problem. So if we have a parallelogram now, let's just sketch a parallelogram. I just want to show you what the formula is, okay, so we don't get confused. So let's say we have a parallelogram of this nature. It's always good to draw a sketch of the situation so um, you have everything clearly labeled. This is the angle theta, and let's call the side B, and let's call the shorter side A. So let's see, A is, we have 32 and 46. So let's call this 46 and call this 32. Now, if you're given a parallelogram with sides A, B, and an included angle theta, the formula for the area is AB sine theta. You might recall the area of a triangle formula that is 1/2 AB sine theta. Well, these two are related. Okay, if you double this double this formula, you get that because a parallelogram is basically two triangles combined with each other. Let me show you the splits right here. Okay, see this parallelogram? You have two triangles, right? Area of this is 1/2 AB sine C. Area of that is 1/2 AB sine C. When you combine them together, you end up with the formula AB sine C. Okay, so this is the formula that we need to use. So step one is write down the formula. And then next, we're going to find out our known and unknowns. Okay, so we know the area. The area is 594. We know what A and B are. A and B are the sides, right? A is 32. B is 46. Now, what is the included angle theta? That is our unknown. Okay, so plug all these values. We substitute them into the equation for the area, and then we'll solve for theta. Okay, so area is 594. 594 equals A 32, B 46 sine theta. All right. Okay, let's go ahead and solve this equation. We can multiply 32 and 46. That will give us 1,472 sine theta. And go ahead and divide both sides by 1,472. We want to isolate theta, okay? That's the plan here, 1,472. Let's divvy up our workspace. Now, if we divide both sides by 1,472, we're going to have sine theta. These two divide out. We have sine theta on the left side, but we can switch it around. We have sine theta equals 594 divided by 1,472. Notice I didn't divide this yet. I just want to preserve accuracy, okay? Now the next thing I'm going to do is get rid of the sine. Now, how do I get rid of the sign so I can have theta isolated? We simply take the inverse sign. Okay, so the inverse sign is the inverse of the sine function. That is the only way you can get rid of the sine function, by using the inverse sign. Please don't try and divide both sides by sine. That is not accurate. All right, so we take the inverse sine of both sides of our equation. This cancels out. And we have theta equals, and then you just basically plug that into your calculator. Now, in this problem, it's in degrees. Okay, so what does that mean? That means that you have to ensure that the mode of your calculator is set to degree mode, or else your answers will be incorrect. Okay, so our calculator is set to degrees. I'm just going to input this expression. Second function sine is the inverse sine of 594 divided by 1472. And then we get 23.7992. So theta is 23.7992. Okay? But we were asked to round it to a specific decimal place. What was it? To the nearest tenth. Okay, so rounding to the nearest tenth, we're rounding to the digit right after the decimal point. So since 9 is 5 or greater, we'll round up. And our final answer theta is going to be 23.8 degrees. All right, so that's that. All right, let's take a look at number 36. It reads, the table below shows the amount of decaying radioactive substance that remained for selected years after 1990. Write an exponential regression equation for this set of data, rounding all values to the nearest thousandths. Okay? And one thing you want to note about exponential regression is that it's just a tool that's used to model data that has an exponential pattern. All right, if the data points are graphed and they look like they formulate an exponential pattern, then the pattern of an exponential function, then you can use exponential regression to model that data. Okay, just like lines of best fit, not every data forms a linear pattern. If they're exponential in nature, then you can always use an exponential regression equation to model that data. Now, what's the benefit of that? Well, you can use it to extrapolate values that are not on your table. Okay, basically fills in the gap and also can be used to predict future values. So keep that in mind. Now, this is a calculator heavy section, so we're going to be using our calculators extensively for this problem. What we're going to do is as follows. We are going to, first of all, activate diagnostic on our calculator. I'll show that to you momentarily. And then we'll enter the data set in the stat edit menu, this entire data set in list 1 and list 2. Then we're going to use the exponential regression function to generate an exponential regression equation. Okay? All right, so let's go ahead and take a look at how this is done. I will be using a TI-83 Plus for this problem. There are different formats for different calculators. So let's go ahead and do this. So first thing we want to do is we're going to turn on diagnostic, okay? So to find that, I will go to my catalog. Everything can be found in the catalog. Second function 0. I'm trying to turn on diagnostic. So diagnostic is under D. So where is D? There you are. Scroll down. Diagnostic on. Press enter. It brings it to the home screen. Press enter again, and the calculator will tell you done. Okay, so it's now active. Now what we're going to do is we're going to enter this information. All right, so this stat button is what we're going to use. Press stat. Now we're going to, it says edit, so we can now edit our entry. All right, so you press your, its edit will be highlighted, so you press enter. Now you have multiple lists here that you can enter into your calculator. In this problem, we have two columns. two rows, which will correspond to the two columns we have here, okay? So the years after 1990 will be entered into column L1, and then the amount Y will be entered in the column L2, okay? All right, so let's enter list 1 or row 1. We're going to have 0, and then just press enter, and then it takes you to the next entry. 2, enter, 5, enter, 9, enter 14, enter 17, enter, and the last one 19, enter. Okay, so where do we go next? We go to the second column, that's list 2, which corresponds to our amount y. So we're just going to enter these numbers in the second column. Okay, we have 750, enter, 451, enter 219, enter 84, enter 25, enter 12, enter 8, enter. Perfect. So we have everything entered now. Okay, now we're going to use the exponential regression function in our calculators to generate an exponential regression equation for this data set. So where can we find it? You can always find things in your catalog or other places. So I'm going to access this function in the stat menu. So I'm going to go to stat and then go to calculate, and you have a whole bunch of statistical tools that you can use here. Let's look for exponential regression. Option number 0, EXP regression, press enter and enter again, and it does this nice little calculation and it gives you the answer. All right, so this is the format right here. Y equals a times b to the x. It tells you what a, b, r squared, and r are. All we care for is just a and b. Let's put it into the equation, and that will be the answer for the first part of problem 36. All right, so let's go ahead and put that down. So we have, where's my calculator? Our answer for the first part is, well, let me show you everything so you don't get confused. Y equals a times b to the x. Okay? In this calculator, it tells us that a is 733.6458 and b is 0.78649. Okay, now we're asked to round to the thousandths. Okay, so thousandths, let me see, is that what we're told to do? Let me just verify. Yes, nearest thousandths. So nearest thousandths is the same thing as the third decimal place, because you have tenth, hundredth, and then thousandth. Okay, so we're rounding to this place and that place. Note in this exam, if you do not round correctly, you're going to lose points. So please pay close attention to your rounding. So our final answer is going to be y equals 733.64. Now, this is bigger than 4, is 5 or greater, so we have to round up. 646, and then that times b, which is 0.78. Now 6 we're not going to round up because this is less than 5, so 786 raised to the x power. Okay, so this is the answer to the first part. This is a two-part problem. All right, so let's shift our attention to the second part. All right, so it says using this equation, determine the amount of the substance that remained in 2002 to the nearest integer. Okay, so you have to be really careful here. Some students will be in a haste to say, okay, x is 2002. So they plug that into this equation and calculate. That is incorrect. If you refer back to your table, remember it states that the input values are years after 1990. Okay, so we have 2002. What will x be? X will be how many years from 1990 to 2002. So x is 2002 minus 1990. That's what we're going to plug into our regression equation. Okay, so let's do that. 2002 minus 1990 should be 12 years. Yes, it is. Okay, so we know what x is. We know what our input is. Now to calculate our outputs, we just simply plug in 12 into this equation we have here, linear regression equation. So we have y of 12 equals 733.646 times 0.786 raised to the 12th power. Okay, and that should give us our desired result. All right, so let's go ahead and calculate that. We have 733.646 times 0.786 raised to the 12. We just use caret 12. Okay, enter. So we are asked to round it to the nearest integer. Our answer is 40.7903. So 40.7903. So if we want to round it to the nearest integer, we're going to round up. So our answer is going to be 41 to the nearest integer. Okay, to the nearest integer. Remember, always pay close attention to the specified place where they want you to round your answers to. All right, let's take a look at problem 37. It reads, use the recursive sequence defined below to express the next three terms as fractions reduced to lowest terms. So fractional results are desired here. Now, one thing you want to note is that recursive definitions involve using previous terms to determine future terms. So you have to look back. What's before me, that's what you depend on for your definition. Okay? So in this problem, we're asked to find the next three. So what we're going to do is we're going to find the second term using the first term and the recursive definition. Okay? And then after finding the second term, we'll use the same procedure for the third. We'll find the third using the second and the recursive definition, and then find the fourth term using the third and the recursive definition. Okay? All right, so let's go ahead and start. We already know what A1 is. A1 is our foundation, which is 2. Now A2 is going to be 3 times A2 minus 1. Okay, A2 minus 1 raised to the negative 2 power. All right, so this is going to be 3 times A1 raised to the negative 2 power. So what is A1? A1 is 2, so we're going to have 3 times 2 raised to the negative 2. Okay, and then this comes out to 3. Now using the reciprocal property of exponents, this becomes 3 over 2 to the second power. If you negate the exponent, then if you flip the sign of the exponent, then you have to reciprocate the base. All right, so we have it like that. And then if you simplify, you have 3 over 4. That is A2. All right, let's go ahead and find A3. A3 is 3 times A3 minus 1 raised to the negative 2 power, which is 3 times A2 raised to the negative 2, which is 3 times, what is A2? A2 is 3 over 4 raised to the negative 2. Now, if we apply the reciprocal property of exponents, this becomes 3 raised to the 4/3 to the second power. Okay? When you reciprocate a fraction, the denominator goes upstairs and the numerator goes downstairs, just like we have here. Okay, now let's go ahead and simplify this. We're going to have 3 times, now you have to square the top and the bottom, okay? Don't just square the top. 16 over 9. 3 goes here 1, 3 goes here 27. Uh-oh, what am I doing? 3 goes there 3 times. Where did 27 come from? 3 goes there 3 times. So our answer here is 16 over 3. That's our third term. Fourth term, same process. We're going to have 3 times a4 minus 1. Remember, n is 4 here, to the negative 2. That equals 3 times a3 to the negative 2. That equals 3 times, what is a3? a3 is 16 over 3. Raise that to the negative 2 power. So what we're going to do now is use the reciprocal property of exponents to express this as 3 times 3 over 16 raised to the positive 2. Okay? And then simplify this. We have 3 times square the top and the bottom. 3 times 3 is 9. 16 times 16 is 256. Multiply across 3 over 1. 3 times 9. 1 times 256. We have 27 over 256. So there goes our next 3 terms. Okay, so let's go ahead and write that down. The next 3 terms are, what are they? 3 over 4, 16 over 3, and 27 over 256. So that's that. All right, let's take a look at number 38. It says the periodic graph below can be represented by the trigonometric equation y equals a cosine bx plus c, where a, b, c are real numbers. State the values of a, b, and c and write an equation for the graph. All right, so one thing you want to note when finding the period of periodic functions just like this, sine or cosine function, this is definitely a cosine function. When you want to find the period, an easy way to do it is by determining or calculating the distance from the horizontal distance from one maximum to the next maximum. So how long is that? Or you can go from one minimum to the next minimum. Calculating those distances is an easy way to graphically determine the period of a function, okay, of a periodic function. So from max to max, that's a complete cycle. So that distance tells you the period, or from min to min, whichever one is easiest to calculate using the calibration of the x-axis, that can do that. And then for your amplitude, half the distance from the max to the min, half the distance from the maximum to the minimum is an easy way to calculate the amplitude of your graph. Remember, the amplitude is not the distance from max to the min, it's half that. The amplitude is the distance from the center, the displacement from the center to the max or min. Okay, now with that in mind, let's go over the steps we're going to use for this problem. First of all, we're going to find a new origin, the max and the min. We're then going to determine the amplitude, period, and vertical shift using the graph. And then we're going to write down the equation y equals ax cosine bx b times quantity x minus c plus d equation, and use that to find a, b, and c. And then when we're done finding a, b, and c, of course, we're going to substitute it into this equation right here to determine what our function is. All right, so let's go ahead and get started. Now, we're going to use this graph to determine the amplitude and period, and also the vertical shift. All right, so the way you annotate this graph is very important. You have to be really careful. Now, first thing we want to do is we want to find where the new origin lies. Okay, so it goes from 4 to negative 2. So let's see. 1, 2, 3, 4, 5, 6. What is half of 6? Half of 6 is 3. So it can go 1, 2, 3. So somewhere there we have our center. This is our center right here. This is our new origin, right there in the center. This is our, let's call this x old. We have an old x-axis. This is our x new. This is the x we're looking at. The y old and the y new are the same. What does that tell us? It tells us that there is no shift in the vertical direction, or I'm sorry, in the horizontal direction. There are no phase shifts in this problem. In this problem, we have a horizontal shift because you see you have an old x and a new x because there's a shift upwards by a unit of 1. All right, so next into graph, we have our new origin right there, 0, 1. We need our maximum. There goes your maximum. And the minimum. There goes your minimum. Okay? So labeling a graph like this helps you to carry out your calculations with ease. First thing we want to do, let's find out our period. So easy way to calculate the period, we talked about that earlier. I like to go from this peak right here, this maximum value, to this maximum value right there. That distance will be my period. Okay? So just project that distance to the x-axis. We're going from 0 to pi. That means our period is what? Our period is pi units. Period is pi. Next thing I want to find is our amplitude. Now, what's the amplitude here? You have to be careful. Remember, the amplitude starts from the center to the max or to the min. So if I go from the center to the max, count the number of units. Don't just write down 4. That's incorrect because you're not starting from 0. Start from 1 and count 1, 2, 3. Your amplitude is 3. Amplitude is a scalar. It does not have sign. You cannot associate a sign with amplitude. It's always positive, okay? All right, now last thing we need is the vertical shift. Vertical shift. Vertical shift in this problem is how high or low the new origin is from the original origin 0, 0. It's 1 unit up, so our vertical shift is positive 1. Okay, another thing I like to put into this problem is the horizontal shift or phase shift. That's also important. So let's write that down. Horizontal shift, also known as the phase shift. Horizontal shift in this problem is 0 because you notice we talked about it earlier that notice there's no movement on the y-axis. It stays the same. The whole graph just shifted up 1 unit. Okay. Now we're done with step 2. Step 3, we're going to write down our equation. Y equals a. This is a cosine function. Remember what your cosine function looks like. It's like a cup. And even the problem tells you that it's a cosine function. All right. So a cosine b times the quantity x minus c plus d. All right. Okay. Now, a is the amplitude. So a in this problem is equal to the amplitude. And what do we know the amplitude is? 3. All right, so we know that 3 is going to go right here. How about B? B, what is B? B is your period. How do you compute the period? B, to find the, well, I got this backwards. The period is not B. The period is something else. The period is 2 pi over B. Okay, period is 2 pi over B, or B is 2 pi over the period. I don't want to write it like that so you don't get confused. So the period is 2 pi over B. We know that the period is pi, so what does that tell us B is? Let's go ahead and figure that out. Since the period is 2 pi over B, and the period is pi, we have the equation pi equals 2 pi over B. Okay? Now how do we solve this equation for B? Well, we can just look at this and figure out what do you divide 2 pi by to get pi? 2, because if you have a 2 here, the 2's cancel out, and you have pi equals pi. All right? But let's just solve it. What we do here is multiply both sides by b, multiply this side by b, multiply this by b, and divide by pi. divide by pi, so that on the left side, the the pi's divide out, and then on the right side, b's divide out, and the pi's divide out also. So what does that tell you? It tells us that b is equal to 2. All right, nice. We have our a and b. Now, next thing we need is a c. C is a phase shift, okay? So c is equal to the phase or horizontal shift. We call it horizontal shift in this problem. So horizontal shift is 0. So since horizontal shift is 0, we know that c is equal to 0. What else do we need? D. Oh, D is a vertical shift. Okay, D is a vertical shift. And in this problem, what is the vertical shift? The vertical shift is 1. So what we're going to do is we're going to plug all these values into this function, and then we're going to be able to generate the equation of our function and also specify what a, b, and c are. Okay, so let's list them first before we substitute. A is 3, b is 2, so c is 0. No, this is big C, okay? In the problem, there is a little c right here. That's not what we're talking about. Okay, we're talking about a big C in this function, in this form of the equation of a cosine function. So be careful. And then D is 1. Now we're going to plug everything into this function and then match it with what we're given. And then we can determine what little a, little b, and little c are. Okay? So let's plug everything in. We're going to have y equals a3 cosine b, which is 2x minus 0, which is c times, plus d. D is 1. Okay, let's simplify further. We're going to have y equals 3 cosine 2x, because 2 times 0 is 0, cosine 2x plus 1. And that's exactly what we want. Okay, so y equals 3 cosine 2x plus 1. What is a, b, and c? In the original problem, we were given the equation y equals a cosine bx plus c. So if you match it up, you can see that a is 3, b is 2, and c is 1. Okay, so let's go ahead and write our answers. A equals 3. B is a coefficient of x, which is 2. C is equivalent to our um, vertical shift, which is 1. And also we have the equation y equals 3 cosine 2x plus 1 as the equation of our function. Okay, so we're asked for two things here, so we want to make sure that we provide both answers. All right, let's take a look at problem number 39, the last problem in this series. It says a homeowner wants to increase the size of a rectangular deck that now measures 14 feet by 22 feet. The building code allows for a deck to have a maximum area of 800 square feet. If the length and width are increased by the same number of feet, find the maximum number of whole feet each dimension can be increased and not exceed the building code. Only algebraic solutions can receive full credit, so that's a point you want to note. All right, now let's go ahead and solve the problem. All right, so one thing you want to note when solving or carrying out algebraic calculations on geometric figures is always use a diagram. All right, in this case, no diagram is provided, so you definitely want to use a diagram to help place your understanding of the problem on the concrete foundation, okay? All right, so these are the steps we're going to use. We're going to sketch the situation and label it fully. We're going to use geometry and the diagram to formulate an algebraic equation. And then we're going to solve the solve the equation with the most efficient method. Now, in this problem, we're asked to solve the problem algebraically, okay? There are other ways we can do it. For example, we can solve it graphically. But if we want to receive full credit, we have to use algebra to solve the problem, okay? At the end, we're going to use a calculator, but we have to show our algebraic steps. So first thing to do, let's go ahead and sketch the problem. So originally there was, um, we had a piece of, what was it again? Oh, it's a deck. Okay, so we're dealing with a deck here. So the original deck had dimensions 22 by 14. All right, so let's just sketch a random rectangular deck. So let's say this was the original deck, um, 22 by 14. And then the owner wants to increase the dimensions in such a way that the area does not exceed 800 square feet, but also he wants to increase the sides by the same length. All right, by exactly the same length. So let's go ahead and do that. Let's color code this so you can see what's going on here. So we're going to increase it by exactly the same length. Let me use blue. So let's say we increase it by x. We increase the width by x units. So what does that mean? We're going to also have to increase the height by x units. And then we have a bigger rectangle right here. Okay? So in this case, the entire rectangle, this entire rectangle is expected to have an area that does not exceed 800. Okay, less than or equal to 800. Okay. All right, so let's go ahead and label some more here. This is x. That's how much the width was increased by, and then the length or the height was also increased by exactly the same amount. That's what the problem indicated to us. So now we've been able to sketch our diagram. We've labeled it fully. Oh, we're not done labeling. We have to label some more. So what are we going to label here? Let's indicate what our dimensions are so we don't get confused. All right, so in this problem, our width, this is our width right here, and this is our height. So our width is 14 plus x. Okay, that's how wide it's going to be. And then our height, or let's call it length, is 22 plus x. Okay, now we have it fully labeled. Perfect. Now, step two, we're going to use geometry and the diagram to formulate an algebraic equation. What is the formula for area? Area of a rectangle. Area of a rectangle, Area of a rectangle is length times width, right? Length times width. All right, so area of a rectangle is length times width. So what's the area in this case? The area is 800. I'm going to go with the maximum area, okay? 800 is equal to the length, which is 22 plus x, times the width, which is 14 plus x. Okay? All right, so what we're going to do is we have to solve this resulting algebraic equation. Okay, the answer gives us the maximum value for x. Anything less could suffice, but we want to look for the maximum. All right, so what are we going to do here? We're going to expand this, of course. If we expand it, we just FOIL it out. First, outer, inner, last. So let's go ahead and do that. First, outer, inner, last. This, we can easily solve this with a calculator, but we're not allowed to do that. So we have to do it algebraically. Okay, so if we distribute, we're going to have 22 times 14 is 308 plus 22x plus plus 14x plus x squared. And that is equal to 0. No, actually it's equal to 800. All right, so it's equal to 800. Now let's simplify this a little bit. I want to write it in standard form. Okay, x squared plus, if you combine the two middle terms, you get 36x plus 308. Now, when you're solving quadratics, you want to make sure it's in standard form before you start to do anything, okay? So standard form requires the degrees to be in descending order and the equation equal to 0. So we have to subtract 800 from both sides of our equation. Okay, subtract 800 from both sides. This is equal to 0. And then we have, what do we have? We have x squared plus 36x minus 492. All right, so we're going to solve this using the quadratic formula. A is 1, the coefficient of x squared, B is 36, and C is negative 492. All right, so plug all this into the quadratic formula. What is the quadratic formula? Let's write it down. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? In this problem, we are asked to give a whole number solution. So if we have a radical result, we have to use our calculators to find the decimal approximation and then round up. So let's go ahead and populate the variables with these answers here. So we're going to have x equals negative 36 plus or minus the square root of 36 squared minus 4 times a, which is 1. Be careful with the c. This is negative 492. We don't want to make sign errors here. And then let's put parentheses there too. That's a good practice. And then divide the denominator by 2a. So divided by 2 times a, which is 2 times 1, which is just 2. All right, let's go ahead and simplify. We have x equals negative 36 plus or minus the square root. Now I'm going to have the calculator do the heavy lifting here, okay, to carry out this arithmetic computation of our radicand. Okay, so we're going to do 36 square minus 4 times negative 492. Notice I didn't use the minus, I used negative, okay? So enter, we have 3,264. 3,264. And then of course it's divided by 2. So 3,264, the square root of that divided by 2. Okay, now we can go ahead and, since we're going to be rounding our answers out, we can, let's split it apart first. So we have negative 36 plus or minus. Let's find the decimal approximation of that. Decimal approximation. Take the square root of the answer we just got. Square root of 3,264. So it's 57.1314. So let's use that 57.1314. Let's write that down. Plus or minus 57.1314. And that entire expression divided by 2. Okay? All right, so this is where we split our answers into 2. We have x equals negative 36 minus 57.1314 over 2, or negative 36 plus 57.1314 over 2. Now, one of these answers makes no sense. Can you determine what answer that is? It is this answer right here. This answer will be negative. Is it possible to have a negative side length? The answer is no. So since this is negative, this is not a reasonable answer. This will be positive because the bigger number is positive and the smaller number is negative in the numerator. So we just evaluate this and round it to the nearest whole number, and that should give us our desired result. Let's go ahead and carry out the computation. So we have that minus 36, enter, divided by 2, and we have 10.5. So answer is 10.5657. So let's go ahead and write that down. X is 10.5657. 56. Now the question is our answer going to be 10 or 11? Can we round up or should we round down? Remember, the area has to be less than 800 or exactly 800. This gives us exactly 800. But since we want a whole number, what is the risk of rounding up? If you round up, your area is going to be greater than 800, okay? So we have to round down. So x is going to be 10. That's the correct answer. If you try x with 11, you're going to end up with an area that's too big, and that will not work. So in this case, you're going to round down because you want to stay within the allotted area. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial, do give us a thumbs up. We appreciate your positive feedback. If you have any questions or you like clarification of anything in this video, or just any questions on the Algebra 2 Trig Regents tutorial in general, just place a comment in the comment section below, and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to other great math tutorials such as this. More clips can be found on mathgotserved.com under test prep. Thanks again for watching, and have a wonderful day.